In this video, we demonstrate how easy it is to program round handrail into EMI's tube processing center using our included proprietary software called Peacemaker. Our first example is this simple straight rail with 4 parts: the top rail, the outer posts, the inner post, and the mid rails. Note that we only need centerline dimensions. Our software calculates the geometry of the notches and miters automatically from centerline, so we eliminate confusion over long point, short point, and notches. So here we go with the first piece. Top rail 60, and the height is 42 to centerline. New piece. We'll call it top rail. We'll make it out of 1.5-inch pipe. We program the actual OD. This is going to be schedule 40. It's 60 inches long. There's one of them in this assembly, this drawing. And at the one end, he's a flat cut 45, and at the other end, he is also a flat cut 45. We have just defined that piece. Then we go to the outer posts. The outer posts are 42 inches tall. There are 2 of them in this assembly. At the top end of the outer post, he's a flat 45, and at the bottom, he's a flat cut 90. When we say flat cut, we mean mitered as a saw would render it. So at the top, he's a flat 45. At the bottom, he's a flat cut 90. We just saved him. The inner post is the same 42 inches tall, because even though this is physically, according to our tape measures, obviously shorter than these guys, by centerline, it is the same dimension. Our software handles the cutback and this end geometry from centerline. So there's one of the inner posts in the assembly. At the top, he is a coped or notched 90, and at the bottom, he is a flat cut 90. We're done with the inner posts. We program the mid rails. The mid rails are half of 60, so they are 30 inches center to center. There are 2 of them in this assembly. And at the one end, he is a coped 90. At the other end, it is a coped 90. By the way, would you happen to want weep holes on these mid rails for galvanize, which will place them right there and right there, which is most common practice. We just added the weep holes. So we go back to our piece list, and we have programmed all of those. Now we go to our batch list, which is where we nest all those pieces into a batch to burn it. We'll just call it handrail assembly 1. And we want all instances of all of these pieces that are in this whole drawing. So 1 top rail, 2 outer posts, 2 mid rails, 1 inner post. And so we select them all, hit auto nest. They are nested into 2 sticks of material. 5 pieces came on the first. 1 piece needs the second stick of material. This is 21-foot pipe stock. And there we go. We save that batch, and we generate the G-code file, the NC file that the CNC needs to actually cut these parts. All done. So let's get rid of those. And the batch as well is gone. Our second example is this sloped rail. So I'm just going to work my way around the frame, naming and numbering the pieces, and adding them into the database, with the posts being last. So here we are. The top rail is 147 3/8. .375. There's 1 in the assembly. And at the top, on a 30-degree pitch, means he'll be a 75-degree flat cut. Let's put in our primary slope is 30 degrees. That way, the common answers are right there in our pick list. And at the bottom, he's going to be a 60-degree flat cut. Top rail is defined. We'll call him lower return 1. And he is 18 inches long. There's 1 in the assembly. And at the one end right here, we know that that's the same 60-degree miter as what's on the top rail. So we already have this end defined. And at the bottom, that's actually a 30-degree miter. So we just change him. We have him programmed. LR2 is 7.062. There's 1 in the assembly. At the one end, we know he's that same flat cut 30. At the other end, he's going to be a coped 60-degree angle. So coped 60 degrees, and we need a rotational offset between the ends. So he's programmed. Then we've got the mid rails. There are 3 of them. They're all the same length. They will be a coped 60 with an offset between them. 45.021. There are 3 of them. Coped 60 at 180. Yes, we would like weep holes on those for galvanized purposes. Then we'll go to upper return 1 is 5 1/4. There's 1 of him in the assembly. And at the one end, he is a coped 60. And at the other end, he's that same 75 degree that was up here. So flat 75. So coped 60. Flat 75. And flat 75. And there will be a 180 degree offset. Save new. Upper return 2 is the next piece. He will be 4.5 inches long with a flat 75 and a flat 45. Flat 75 and a flat 45. And he will need the same rotational offset. He's programmed. Upper return 3 is 18 inches with flat 45s at both ends at 0. Flat 45, flat 45, 0 offset. Upper return 4 is 4.5 inches with a flat 45 and a flat 75. A flat 45 and a flat 75. Save new. And then the posts. All 4 posts are the same. They will be a coped 60 at the top, mitered flat cut 60 at the bottom at 39.688 tall. And there are 4 of them. 39.688. 4 of them. There'll be a coped 60 at the top and a flat 60 at the bottom with 180 degrees in between them. I think I just programmed all my pieces. 2, 3, 4, 5, 6, 7, 8, 9 pieces. 1, 2, 3, 4, 5, 6, 7, 8, and the posts are 9, so all 9 pieces are programmed. And let's go batch them. And this is a pitched rail. We want want to burn out the entire rail all at one shot so that the welder has everything he needs and nothing more all at once. So it got into the third stick of material. A few pieces come out on the third stick of material. Got 3 pieces on the first stick with very little drop. 2 pieces on, or 7 pieces on the next stick with a very small drop. And then, only needed 45 inches or so of the third stick of material. And we go update G-code. We now have the NC file to load in the machine to burn these pieces. So this rail would take a few minutes to load the machine and cut all the pieces ready to weld. So there's no need, as you can see, there's no need to model the rail. There's no need for an engineer in an office with expensive software. Anyone who can read the prints and use a computer can program the machine for round material. The pieces come off the machine weld ready and fit together like puzzle pieces, so well that you not only save sawing time, but you also reduce your weld prep, or reduce or eliminate your weld prep. You even save some layout time, and you make a better weld reveal so that your welds are cleaner, which reduces your weld cleanup time. See here. So, however many minutes it's been in the video, to go from a drawing in your hand to a whole rail assembly programmed and tested, ready to cut out in a few more minutes and right to the weld table. So all in all, programmed these two and could have burned these two all in the same 10 minutes. Thank you for watching.